ऑल राइट। तो हमने प्रीवियस क्लास में कंफ्यूजन मैट्रिक्स स्टडी किया एंड कंफ्यूजन मैट्रिक्स इज अबाउट क्लासिफिकेशन मॉडल evaluation. Why? Because our model do predict classes or categories, and the way to evaluate such kind of models don't require MSc or MAE. No, because the predictions are discrete or categorical in nature, they are not continuous, so we are cancelling such things and we are focusing upon the accuracy and okay classification report also, confusion matrix also. Fine. So confusion matrix we studied for binary, for multi classification also in the previous class, and there I do explained the terms like true positive, true negative, false positive, false negative, positive and negative. These are the two classes. Okay, positive and negative, these are the classes. If your model predicts a positive class as positive and negative class as negative, then only they become true, else they become false. Okay, using these terms I can have some ratios. Okay, and these ratios accuracy I guess we have seen. Okay, for accuracy you have written TP plus TN divided by TP plus TN plus FP plus FN. That means all the instances, all the values, all. And in the numerator, we do have true. True divided by all. So it's like this: true divided by true plus false. That will be accuracy. It's a percentage value. If you multiply this thing with 100, so we are going to get the accuracy in percentage. Okay, fine. Apart from this, we are having the terms like precision, recall, F1 score. These terms are also present. So precision, we say that it is the ratio upon of TP upon TP plus FP. That means true positive upon true positive plus false positive. The ratio of these terms is said to be a precision, where we are taking P positive for only the positive instances. Okay. Recall is the ratio of TP upon TP plus Fn. Okay. So TP upon TP plus Fn. What is Fn? For Fn, false negative. False negative. That means by mistake, model mark them as negative, but it should have to be positive term. So in recall, I think here is the number of all positive terms. All positive. However, in precision, we are having the number of true positive is obviously the positive which are correctly predicted by the model. False positive means which are negative but model predicted it as positive. So they are false. But recall means total number of positive terms, all the positive terms. In the denominator here and in the numerator it is still TP. F1 score is the harmonic mean. It's a harmonic mean of precision and recall. These terms also define the behavior of model because they are telling about how these positive and negative, these labels positive and negative, these targets are identified by model. That means your model is with balance in predicting P and N because you will be making classification report where precision, recall, F1 score is present for both outcomes. If you are considering binary outcomes, let us say this is positive, this is negative, so their values are present. If it is recall, if we check about the recall, and for positive if we say, so it will let you know that out of total positive how many positive are detected correctly. Okay. And in recall for negative it will be like that: false, okay, I can take two negative, true negative upon true negative plus false positive. It will tell how your model predicted negative instances. So the values which are present here, they should be in a balancing mode. It should not be like one value is predicted it is having good scores and another is having low score. That means your model is much more aligned towards a particular prediction, towards a particular value. No, I don't want that. If you say that it's not only about the accuracy, it's not only, it's not only about, okay, sir, I got 98% accuracy, sir. I trained a classification model and sir, I get 98% accuracy. No, it's not only about that. It's about how your model predicts 1 and 0 in balanced way. There should not be any biasing. It should not be biased towards any particular value. We never expect the model biasing. That is the reason whenever you do train your machine learning model or any deep learning or any data you take for training purpose, you have to balance it. If you're doing classification problem, definitely you have to balance your data. Don't train your model if your data is unbalanced, else it will get biased towards a particular value. Okay, got this thing. So let me share my screen and help you in understanding these terms again. This is the entire screen. Okay, and this is what the confusion matrix I have already explained. And precision, I gave you the formula, recall formula, precision, recall, F1 score. Precision is like its name is this only. However, recall you can also name it as sensitivity, another name. F1 score is a harmonic mean of precision and the recall. Then we do have ROC and AUC curve also for classification model evaluation. ROC AUC curve. So ROC means receiver operating characteristic, characteristic, while AUC means area under curve. That is AUC means. So ROC and AUC. So far, what we have understood that, sir, you should be clear with the problem. You are dealing with classification problem, so you expect a classification model and data should be given to it in a balanced way. Then your model will give you a score that you called as an accuracy score. Further, you have to evaluate your model by printing confusion matrix and classification report. In classification report, you have to check about the balancing in the different classes in terms of precision, recall, and F1 score. You have to check it. That how your model showing a behavior towards a particular class. If your model is behaving towards a particular class like 70, another class is 30, that means it is aligned to this particular class. However, the nature which I am expecting here is 0.51, 0.49. Something like this is good. Or you will say, we'll see some more cases where, okay, this will also, I think it's a less. I guess if we are having zero point 0.9, zero point 0.9 for both of them, like for class 0 also, class 1 also, for both the classes I am having a good prediction. My model is able to understand these classes. It's a good thing. Okay, let me show you one classification report which we have printed above. Okay, we do have. This is confusion matrix and this is classification report. Now you can see our accuracy for Iris was 100%. Accuracy 1 means 100%. When I printed confusion matrix, model is not at all confused in any of the class. You can see 10 0 0 0 9 0 0 0 11. That means model understand everything. Then I printed classification report and here you can see precision 100%, recall, FL score all are 100%. That means model don't have any false thing in its record. Whatever it is predicting, it is true. So here you can see 100%. 100% precision recall, F1 score 100% here also. So this is balanced. My model is not aligned towards any particular class. So it's balanced. Support means okay. Support means number of 0, number of 1, number of 2. So I am having 10 plus 9, 19 plus 11, 30. I am having 30 values in which 10 are 0, 9 are 1 and 11 are 2 in my test data. Because classification report we do make between the predicted and the test data. Okay, that is the support. Fine. Now we have few more terms before I catch up AUCROC. Accuracy is known to you. So accuracy is 100%. Apart from that, I am having macro average and weighted average. What does this macro average and weighted average means? Because none of the people do explain about these things. I have explained you precision, recall, F1 score, support is the total number of terms for each class. Accuracy, I already explained macro average. Macro average means this plus this plus this divided by 3. Average, na? So I need to take the average of the values which are present here. So 1 plus 1 plus 1 divided by 3. Answer is 1. Same here also. Same here also. Macro average. That means the average precision, average recall, and average F1 score. Okay. Weighted average. Weighted average means 10 into 1. See here. 10 into 1 plus. Okay. Then 9 into 1 plus. Then 11 into 1. divided by 10 plus 9 plus 11. Okay, so for weighted average, you have to perform the multiplication of the support with these values. So 10 into 1, 9 into 1, 11 into 1 divided by 10 plus 9 plus 11. ओके तो ये है ऊपर भी इन द न्यूमरेटर ऑल्सो आई एम गेटिंग दिस इन द डिनोमिनेटर ऑल्सो आई एम गेटिंग दिस आंसर इज 30 by 30 it is 1. This is weighted average. Okay, so one is the macro average, that is the simple one. Another is the weighted average, and this is how you do calculate it. Okay, got it. So these terms I want to explain you in classification report. So confusion matrix is all clear, classification report is all clear. Apart from these, we have to make some more plots. So they are ROC curve, receiver operating characteristic, and there is no specific formula for ROC. It plots between it give a plot between true positive rate against false positive rate, TPR and FPR. TPR, FPR. If I am going to make a plot between TPR, FPR, this is ROC, receiver operating characteristic plot. True positive rate. What is your true positive rate? It's mentioned. True positive rate. Formula for it? No. See, it is a graphical representation of the true positive rate against the false positive rate at various thresholds. Currently, the threshold is zero point 0.5 for us. We are talking about logistic regression, binary classification. So our threshold is zero point 0.5. Okay, and AUC, a scalar value summarizing the model's performance across all classification thresholds, area under the curve. So, true positive rate. What should I write for it? TPR. TPR is equal to TP upon TP plus FP. I think this should be TPR, true positive rate, isn't it? And what about false positive rate? What will be the formula for false positive rate? Yes, if we write this thing, true positive rate, then what should be the false positive rate? I think we have to change the formula, and it will be Tp upon Tp plus Fn, because I need to talk about all positive. That should be the true positive rate. And false positive rate will be false positive upon false positive plus true negative. This should be the false positive rate. And what does it mean? TP rate means what? It means that number of instances correctly classified for a given class. Our class is P. So the number of instances correctly classified for P is given by Tp upon Tp plus Fn, because these are total positive, and these are which are correctly classified as P. So that is Tp. So Tp upon Tp plus Fn, true positive upon true positive plus false negative. And what is false positive rate? Which are wrongly classified. That means these all are wrong classified. FP, false positive plus true negative. So instances which are falsely classified as a given class. So let us suppose your given class is P. That's what I'm talking right now. So false positive, wrongly classified as P, divided by false positive plus true negative, which should have to be true negative, which should have to be negative, but it is falsely positive classified. I need to find the rate between them. That is called as receiver operating characteristic. Again, understand, we are still evaluating our model, and we are looking forward that how our model is performing over a data. There are two terms mentioned here: true positive, okay, true positive, sir, we know, and false positive. So this also we know. True positive means truly classified positive values. False positive means wrongly classified positive values. So in true positive, they are actually positive, and model also classified them as positive. False positive means they are actually negative, but model classified them as positive. That is why they are false positive. I am adding a rate. So rate will obviously it's a ratio. So TPR, I said, true positive rate means true positive upon true positive plus false negative. That means all the positive instances, all positive divided by positive which your model predicted. This is also recall. This is a formula for recall. Now, FPR means false positive rate means okay, false positive rate. So, what's mentioned in false positive? Here, false positive, I told FP upon FP plus TN. This is false positive rate. So, false positive, true negative, that means all negative divided by, okay, this is all negative. In numerator, I am having false positive. That is, which are wrongly classified as positive, but they should have to be negative. So This is wrong positive, wrongly classified as positive. If you make a plot between these two, that's called as ROC, receiver operating characteristic. And and in general, TPR and FPR, it's like this, something like this. There is a curve like this mentioned. There's a curve made like this. Let us consider from 0 to 1. So this is area under the curve. AUC, area under the curve. If this curve is like much more wider, means your model is good. Its performance is good. But if the curve is not that much covering the area, or it's narrow, so area present in the curve is less. That means model performance is poor. Okay, therefore we expect that area under the curve should be more. If you make AUC ROC curve, that is what it's called, AUC ROC curve, or plot, whatever you want to say, you can. We are defining the rate of our model's predictions. Whatever be the ratio which I have taken so far, they are defining the rate of the prediction done by the model related to positive and negative. And if you make an area, it is saying that it's a summary, it's a summarization of all thresholds. That's what it's mentioned here in the definition. Okay, we can see a scalar value summarizing the model performance across all classification thresholds. We do have a threshold. Zero point 0.5 is my threshold. For logistic, that's only what we consider, zero point 0.5 as a threshold. Okay, this is your logistic curve. This is your threshold, zero point 0.5. So it is saying that summary of the predictions done by the model for considering this as a threshold, that is called as AUC, area under the curve. And I already told you, area should be more if you want to see, understand that your model performance is good. Because ultimately, again, the definition is same. We are still evaluating our model. We are still checking the performance of our model, summarizing the performance. Whatever I am doing here, I am considering the performance of the model only to check it, how model is behaving. So whether it is ROC curve, whether it is AUC curve, or whatever, model performance is being checked. We are having a code for it. Okay, fine. I hope, yeah, here it is. For Iris data, it's a very simple data. Accuracy, I already got 100% in this. So I took the series data, I performed the training of the iris data, I performed the prediction also based upon the iris, And then this is how you can compute FPR, TPR thresholds, ROC curve, Y test and the Y score. That means these predictions you can put here in the ROC curve. So this will give you FPR, TPR values and the thresholds. Okay, and here the point is, sir, kindly print the thresholds also, sir. Can we print the thresholds? Okay, so let me take this code, and we will be printing the TPR and the FPR and the thresholds also. Okay, it's better to understand each and everything. Okay, so let me run this code. We already know that logistic regression will give 100% accuracy on erased data. Okay, so we have trained our model, and now I want to print FPR, false positive rate, FPR. These are the values for FPR. TPR, these are the values for TPR, true positive rate. And this is the thresholds. These are the threshold values for them. We need to find ROC curve based upon Y test and the Y scores. Y scores are the predictions. Y test are the actual value. So if I need to make ROC curve between these two, this is what I will get as a parameter. Okay, so FPR is this thing, TPR is this thing. These are the threshold values. Okay, and then there is like we do have AUC curve also. So AUC I can compute by taking FPR and the TPR. So let me put it here again in this code. Okay, that is 1. So area under the curve is 100%. All the points are captured. There is nothing remaining. 100% area under the curve. And what is the plot? How it look like? This is how it looks. So false positive rate, these values from 0 to 1. True positive rate, values 0 to 1. So TPR and FPR are between 0 to 1. This dotted line, okay, I am having a red line, diagonal line. Okay, that's diagonal. X limit and Y limit I am taking from my side as 1, between 0 to 1, 0 to 1. That's what I am taking. Okay, and here I am plotting FPR and the TPR values. Okay, so you can see there is a blue line matching till 1, and here it is putting the entire, like, connecting this line to the dashed. So since you are having already 100% accuracy, fine. So this is your dashed line, this is your red, it is connecting this. So entire area, this is equal to 1. Area under the curve, it is 1. That is AUC. AUC. It's not mandatory. It can be like this also. Then it's like zero point 0.7, zero point 0.8. In that particular case, your model is not that much good. Highest is 1 for AUC. Area under the curve should be 1. That means your model is working perfect. Rest zero point 0.7, zero point 0.8 or zero point 0.5, then average and then good, and this is how we can define. Okay, fine. They told there is no specific formula for ROC. Nothing, no specific formula. Only for ROC, they told कि you have to make a plot between TPR versus FPR. There is no formula for it. TPR versus FPR. Just make a plot between these two. This is TPR. This is FPR. So whatever be the true positive rate, okay, let me put a value, FPR value, TPR value, FPR value, TPR value, FPR value. Okay, just put the points of TPR, put the points of FPR. You very well know these ratios. TPR, you very well know TP upon TP plus FN. FPR, FP upon FP plus TN. So you know about them. Okay, just plot the points. Okay, we are having after plotting. Okay, you are getting some dashed line or some. Okay, it's not like mandatory. I just took a dashed line. That's a diagonal line. Always been taken a diagonal. Here you can see TLT dot plot 0110 color red line style diagonal. I need to make a plot between these two. That is blue in color. That is blue in color. Okay, so right now the blue line which you are seeing is from here to here. That is a blue line. This diagonal is just a reference line. It's just a reference line. This is your TPR and FPR. And whatever be coming inside this TPR, this is AUC. So receiver operating characteristic is a curve you are getting. Curve hai ya whatever you are getting. Area inside this curve is AUC in consideration with the diagonal line. Okay, consider a diagonal line, and whatever you are getting from here, just this is AUC, area under the curve. Okay, these terms are now not everyone get indulge till this AUC, ROC in classification. The only things which the people do follow is okay, calculate the accuracy and just to print the confusion matrix classification report. Maybe you can print precision, recall, F1 score also. You can print these values. But now you understand what is present in classification report, that macro average and the weighted average. Okay, you have a knowledge about all these terms. What is this means? And I am talking about the rate now. Rate, that means how model is performing over what? In predicting the values of 0 and 1 in form of TPR and the FPR. Okay, so TPR and FPR values I printed here. Okay, this is FPR, this is TPR, respective values. Okay, and we have plotted them, and then we the area is area of the shaded region here. Okay, I can shade this, and the area is coming to be 1. Okay, area is 1, and okay, how much will be this length? How much will be this length? It's 1. Okay, this is 1, and this is also 1. No? Okay, fine. And this is the diagonal, the red one. So area inside this entire, that is considered to be here AUC, and it's 1, calculated according to TPR and the FPR. No specific formula mentioned. If I say this is triangle, but it's curve, we have to consider this thing is in form of curve, not by just taking simply it a triangle. It's a curve. That is why in AUC it's mentioned summarization. Summarization for each value, for each predictions you have to perform summarization. For summarization is written like this: summary, summation, summation, and then area, or either you can say it's integration. So if I need to calculate the area, I need to integrate from 0 to 1. And what that function looks like, that function is like a triangle. So triangle is half base into height. Dot, I need to take some differential also here, dx or something like that, something I need to take. Okay, so that is entire, this entire is looking like a triangle. If I can take a small strips here, small strips in triangle, for example like this, that is how your triangle looks. If I take a small strip, this is a small strip. Oh, and let us consider that okay, this is a rectangle, its value is 1. So integration 1 dot dx 0 to 1. So it will be integration, okay, integration of dx will become x 0 to 1, and it will be 1 minus 0 equal to 1. So therefore area is 1. This is how you calculate the area. Got it? By using integration. They haven't mentioned any formula, but according to my knowledge, I'm explaining this thing. Got it? So we can calculate TPR and FPR also. Okay, fine. All right, all right. Let me stop it now.